We're supposed to find the volume V of the solid obtained by rotating the region bounded by the given curves about the specified line. The line is y equals 6 minus 3/2 x, which we have graphed here in red. Then the region is bounded by the line y equals 0, which is the x-axis. The line x equals 0, which is the y-axis. And the line x equals 1, which is this vertical line. Now what we're supposed to do is take that region, so I'll shade that in blue, and rotate that around the x-axis. So when we do that, if we were to draw a little representative figure here, it'd come around here, and it'd look like this, and it would be a kind of a disc. And so what would happen is we'd have the area of that disc times its thickness, and we would have the volume of that disc, sort of like a coin. Except this coin doesn't have an edge that is perpendicular to the surface that it's sitting on. Rather, it has a beveled edge. So we think about, well, how do we find the area, the volume of a cylinder like that? We find the area of a face and then multiply it by its thickness. So in order to do this, then we'll find the area of this face, which would be, area is found by pi r squared for a circle. Well, the radius is going to be then this line 6 minus 3/2 x. In order to find a radius of this thing, it'll just be whatever y value we have. So the distance between the x-axis and this line, 6 minus 3/2 x. So the area then will be pi times the square of that radius. And we could simplify that a bit by multiplying that out. We would have 6 minus 3/2 x times 6 minus 3/2 x. So that area will be pi times 36 minus 9x minus 9x, so minus 18x, and then plus 9/4 x squared. Now then, in order to find this volume, then we will integrate from 0 to 1. So we're going from the y-axis, where x is 0, to the line x is 1. And the thickness then of this thing is dx. It's the differential from one place to the next if we were to make infinitely many disks out of this thing. So we're integrating from 0 to 1, the area of a face of this thing, pi times 36 minus 18x plus 9/4 x squared dx. And we can pull that pi out front, so we'll have pi times that integral 36 minus 18x plus 9/4 x squared dx. And then this integral is going to be pi. This is from 0 to 1. I forgot to put the limits there. Pi times 36x minus 9x squared plus 9/8 x cubed. Sorry, that will be 3/4 x cubed. Evaluated from 0 to 1. And when we put 0 in each one of these terms, we're going to get 0 because each one of them has an x. So we really only need to worry about substituting the 1. So we have pi times 36 minus 9 plus 3/4. And 36 minus 9 is going to be 27, but we need to make fourths out of that. So we'll have pi times 108 plus 3/4, which will give us 111 pi.